This video demonstrates Vertify's Dome platform securing a currently installed building automation system from cyber attacks, protecting tenants, a building's assets, and its reputation. The demo system, now shown on the screen, has been assembled in Vertify's lab. This system, running on a BACnet IP network, includes a building automation controller, an event logger capturing network traffic, and an attacker who has gained access to the building's network. The lab includes several real BACnet building devices like this thermostat, and shown here, Vertify's bump in the wire component. Bump in the wires are easily installed by simply plugging the network into one port and a building device, in this case a thermostat, into the other port. All Dome-enabled devices are designed for zero-touch onboarding, ensuring that every device is correctly provisioned in a matter of seconds. This is a simple schematic of our actual lab setup that we'll be using for reference during our demonstration. As you can see, it has our building automation controller, a bump in the wire, an event logger, an attacker, and an installed unprotected thermostat. You will also see reference to S-Link on the network connections. S-Link is our secure tunnel running over a public network, like BACnet. Our first demonstration will show a typical BACnet system with no security, as illustrated in this diagram. The dialog box on the left is a video capture from the building automation controller screen. A user can change the set point and temperature by sending a command to the thermostat. The thermostat will message back that it has successfully received the command. We are using a monitored tool called Wireshark that listens in on network traffic and displays the captured data on the screen. The top panel is a list of all of the data packets that are captured on the network. It can include the source of the packet, its destination address, and Wireshark can even identify the protocol, which in this case is BACnet. Notice the summary information in the last column, providing further packet details. Please remember this for later reference. The middle panel will show you the readable contents of a packet. The bottom panel shows you the bytes of the packet, actually as captured in hexadecimal, a number system used to make computer binary code more readable. We can click on a packet in the top panel and see the packet contents open in the middle and bottom panels. You can see the building automation messaging, and so can everyone who has access to a building's network. Data collected here can be used to monitor building activity and identify how and where to send an attacker's commands. Without security, an unauthorized user can also go on your network and issue a command. In this case, they may want to make the building too uncomfortable to be occupied, but just as quickly could attack your lighting, access controls, or elevators, perhaps for a ransom. With no security, a building device will perform a command, not knowing whether the source is authorized or not. Now let's insert a bump in the wire device back into our network, as shown in our network diagram. We can have the authorized user send a command to the thermostat. A key feature of Dome is the transparency of the security to the building system. As before, the user adjusts the set point and sends a command, and we see the thermostat acknowledges the message. But let's look at the Wireshark monitor and see what just happened, and the difference from our first look at the data packets over the network. We immediately see that the top panel is no longer giving us information on the data packets as we saw earlier. Now, the last column simply says Security Payload. When we click on a packet, the middle panel only reveals a signature, authenticating a message, and an encrypted payload was passed. No other information is available here, and the bottom panel is showing unintelligible encrypted data. An attacker on your network is now getting no usable information. So what happens when an unauthorized user tries to issue a command? The first thing you will notice is that no usable data is coming back to their automation controller, because they do not have the right credentials to get onto S-Link, our secure tunnel transport running over BACnet. But that does not prevent them from sending a command. Now, when they issue a command, you'll see that our bump in the wire has rejected it. The screen you are now looking at is a console view from the bump in the wire, showing how it could not authenticate the unauthorized user's commands and drop them. A key feature of this console function is the ability to capture all of the data packets from the attacker and report them to a building security dashboard. So you are not only protected, but perhaps on your way to identifying and addressing a network security issue. Finally, let's see what happens if an unauthorized user tries to use valid Dome credentials from another building, or perhaps replays a message from another facility. Again, the commands are rejected. And looking at the bump in the wire console and the last two lines, you can see that the bump in the wire device recognized the protocol as correctly formatted, but when it went to authenticate the command and set up a secure tunnel, the credentials were invalid and the command was rejected. This concludes our demonstration of Dome on a pre-existing BACnet platform.